Throughout time, many soothsayers, cultures, and religions have tried to predict the end of times. Be it the 2012 phenomenon or the 2000s Y2K computer virus, or even as early as 365 AD, where Hilary of Poitiers predicted that the world would end the same year. The list is a pretty hefty one. So far, these apocalyptic events haven't necessarily come to fruition, but a collision of two supermassive black holes would certainly be the end. Or could it? Astronomers believe we may be on the verge of witnessing this, but how long do we have? And what's actually going to happen? As dangerous as they could seem, supermassive black holes are an integral part of the universe. But we're not really sure what could happen when two hungry monsters like these are on a collision course. The data on that is a little patchy.
So we know nowadays that black holes are not only mathematical abstraction of the theory, but they are astrophysical objects. And we know actually in the universe now there are at least a couple of tens of black holes in our galaxy with a mass comparable to the mass of our Sun, or slightly larger, 10 times, 20 times larger.
Researchers have recently found some strange activity in a galaxy 1.1 billion light-years away, hinting that it may be home to an awaited occurrence like this, and one that has gotten astronomers at large brewing with curiosity. The galaxy we're talking about is quaintly named SDSSJ 1430+2303, and scientists have found fluctuating discrepancies in light readings from its center. This suggests that a pair of supermassive black holes with a combined mass of about 200 million suns are headed towards each other for a massive collision event. Like everything else that is expected in the cosmos, an imminent collision like this could take up an astronomical amount of time. But researchers believe that if the signal is caused by massive black holes, they will combine within the next 3 years. This could be the greatest chance for us to witness the collision of two supermassive black holes and understand what's really going on there. The problem here is that astronomers are not completely sure if it's the exact activity taking place at the core of J1429+2303. But to be honest, that name is a little too complex to keep saying, so for now let's just call it Galaxy J. Scientists have been keeping an eye on the odd galaxy to see whether it can be definitively identified. Back in 2015, researchers discovered small colliding black holes, a majority of which have so far included binary pairs of black holes with masses similar to individual stars. The discovery marked the beginning of a brave new era in science. Numerous more observations have been made since then through the understanding of gravitational waves sent vibrating through space-time by these colossal events. But we haven't come across something as big as this. There's a reason we haven't as yet. The gravitational wave detection equipment, LIGO and Virgo, are intended for a similar mass range. The more heavy vibrations produced by inspiraling and merging supermassive black holes with masses ranging from millions to billions of times that of our Sun are too low for our existing observatories to detect. For those of you wondering what inspiraling is, it is describing the paths of a pair of binary stars that are losing energy and spiraling in towards each other. For us regular folk, a phenomenon like this would be terrifying to say the least, but if you're a researcher, an observation of the merging of two supermassive black holes would be an absolute treat. Even in the absence of a detector capable of detecting low-frequency gravitational waves, scientists anticipate a massive eruption of light across the spectrum. The information packed within the outburst could give us a lot of data about the unfolding of these events. We don't know exactly how supermassive black holes grow so huge, but there are a few hints that one possibility is binary mergers. We've come to know that galaxies have supermassive black holes in their centers, and we've seen supermassive black holes orbiting each other in mutual declining orbits. These lie at the center of these post-merger galaxies, not simply pairings or at groups of galaxies merging. We can identify these phenomena from fluctuations in the light released by these galaxies' galactic centers on regular time frames, implying an orbit. This points us back to Galaxy J. Earlier this year, a group of astronomers led by Ning Zhang of the University of Science and Technology of China accepted and published an article on the preprint server RXIV detailing some unusual activity. Over a 3-year period, the fluctuations in the galactic nucleus became shorter and shorter from around a year to barely 1 month. Like most things in our universe, it's not totally obvious that what's going on at the core of Galaxy J is because of a black hole binary at all, let alone the idea of it on the verge of exploding. Galactic nuclei are some of the strangest places in the universe, emitting signals that are difficult to analyze, which might very well mean that something else could be behind the variability in Galaxy J. Astronomers used X-ray wavelengths in hopes of getting to the real root of the problem. Miming Do of Guangzhou University in China led a team to understand the high-energy signs that we would anticipate during such an event. The observation of a close supermassive black hole duo on a D-orbit burn using data from a variety of X-ray observatories during a 200-day period. They observed changes in the galaxy's X-ray brightness as well as a sort of emission consistent with iron falling onto a black hole, which the scientists detected with 99.96% certainty using 2 distinct sensors. This radiation has been associated with binary supermassive black holes. The research, unfortunately, was not able to find concluding evidence that would prove a binary black hole. Adding to that, radio observations analyzed in July were also inconclusive. Mysteriously, it appears that we are still unsure about what is going on with Galaxy J. From the looks of it, Galaxy J's center is turning out to a mystery only future analysis will unveil. Above everything, whether it's a supermassive black hole binary on the verge of colliding, Galaxy J is actively being monitored and needs closer, more extensive scrutiny. The answer to that question is a little disappointing. For starters, we don't know exactly how these huge, enormously dense objects took shape, nor what triggers a fraction of them to start devouring the surrounding matter at extremely intense rates, radiating increasingly across the electromagnetic spectrum and turning their host galaxies into active galactic nuclei. So, when 2 supermassive black holes collide during a merger of galaxies, we expect them to release gravitational waves, like fluctuations in the fabric of space-time. Several simulations have predicted that these mergers, unlike those of their regular black holes, emit both gravitational waves and radiation. The radiation originating in the hot interstellar gas of the 2 colliding galaxies stirred by the black holes' pair when they fall towards one another. But these are merely simulations. Although simulations help us understand the bounds of space, they might not be completely accurate. The truth is, we've never observed merging supermassive black holes, and we might not really know what happens. We do not yet have the facilities for such observations. Combining the observing power of 2 future ESA missions, Athena and Lisa, would allow us to study these cosmic clashes and their mysterious aftermath for the first time.
And that X-ray signature can be measured by Athena, and Lisa measures the gravitational waves, and together we get everything. We get the environment of the black holes. We get the black hole mass, the environment, the location. It really just gives a whole wealth of information you can't get with one or the other instruments.
We will need Lisa to detect the gravitational waves and tell us where to look in the sky. Then we need Athena to observe with high precision in X-rays to see how the mighty collision affects the gas surrounding the black holes. Maybe in the 3 years that has been prompted, we'll be able to understand what in the universe is happening out there, especially on Galaxy J. But till then, we might have to sit tight and ponder. So, what do you think? What's really going to happen when these supermassive black holes collide? What more could be happening at Galaxy J? And how long till we get to know? Tell us in the comments below, and as always, thanks for watching Space Rumor.